Good morning and welcome to SAT Prep for Tuesday, April 28th. Today we're going to revisit the topic of trigonometry, and the questions that we have to answer will address, of course, basic trig functions. So just to remember our basic trig, we had this mnemonic device called Sohcahtoa, and what it told us was that the sine of an angle, we usually use the Greek letter theta, the sine of an angle is equal to the opposite side of a triangle over the hypotenuse. The hypotenuse of a triangle, again, is the longest side, the one opposite the right angle. The C stands for cosine. The cosine of an angle, theta, equals the adjacent side divided by the hypotenuse. The hypotenuse will never be called the adjacent side. It's always called the hypotenuse. Adjacent means next to. And the T stands for tangent. The tangent of an angle theta equals the opposite side over the adjacent side. So if you look at a triangle, such as this one, this applies to right triangles, so we do have to be given that there is a right angle, otherwise there is no hypotenuse and this falls apart as described. We want to look to solve a certain problem. Let's just say my angle theta is this angle down here, and I know two sides of this triangle, the 8 here and the 10 there, and we're asked to find, in our example, cosine theta. So, cosine theta, cosine in Sohcahtoa is the adjacent over hypotenuse. So theta is made up of two sides. Every angle is made up of two rays that come together at the vertex to form the angle. Now, angle theta has a length of 10. That's the hypotenuse, though. And a length of unknown, that's an x. I don't know what that is, but that's the adjacent side. So it's 10 over something, and I say 10 over, but I'm putting it upside down, because it's adjacent over hypotenuse. Adjacent is the unknown. 10 is the hypotenuse. How do I find the adjacent side? Well, trigonometry is also very closely tied to the Pythagorean Theorem. The Pythagorean Theorem, I'll spell that for you. It's Pythagorean Theorem, and that's simply a squared plus b squared equals c squared. The a and the b are the two legs of the triangle. Legs are not the hypotenuse, it's the other two sides. And c is the hypotenuse of the triangle. So in order to use the Pythagorean theorem, we have to identify our three sides. I have an unknown side, call it a if you want to. I have a leg, the 8, we're going to call that the b side. And I have the hypotenuse of 10, that's the c side. So I need to do this first. I need to solve for the missing piece. So I'll just say x squared plus 8 squared equals 10 squared. X squared plus 64 equals 100. Squaring, of course, means multiply by itself, so make sure you square the values correctly. I'm going to subtract 64 from both sides, and I get x squared equals 36. I'm going to square root both sides, and x equals 6. So I figured out that my missing side is a length of 6, which means the cosine's numerator is 6. So the answer is 6/10. All right, and you could just write 6 over 10. If it's a grid-in, you can call it 3 over 5 to reduce it. You can call it 0.6. Any of those are appropriate answers. All right. One more example of using trigonometry, and then I'm going to actually set you free to work on today's assignment, which is attached to the Google Classroom announcement. So I'm going to give you another problem similar to this. I'm going to leave the trig and the Pythagorean theorem on the board. I'm going to give you the follow-up question. All right. I'm going to say this. Ready? If tangent theta equals 3/8, I want you to find the sine of theta. Now, I didn't give you a diagram, but hopefully you understand that this is much easier to solve if we make a diagram. So you're going to make your own triangle. Obviously, you're just going to make a simple right triangle. Identify the right angle. Now, theta is never going to be the right angle. Theta is one of the two undefined angles. You can call it whichever one you want. It doesn't really matter. So I'm going to call my theta down here again. And if that's theta, and I was told the tangent of theta is 3/8, and I can see the tangent is opposite over adjacent, I've been given side lengths. The opposite is this side right here, and according to my information, it's a length of 3. The adjacent is this side over here. It can't be this because this is the hypotenuse. So the information I was given allows me to make my triangle. Now, the sine of an angle is the opposite over the hypotenuse. So the sine is going to be 3 over the unknown side. I have to solve for that side again using the Pythagorean theorem. I'm going to call that x. This time I have the 2 legs, I just don't have the hypotenuse. So I'm going to say that 3 squared plus 8 squared equals x squared. See, this time the missing piece is the hypotenuse, the C leg. So 9 plus 64 equals x squared. All right, so what is 9 plus 64? 73 is x squared. Now, I'm sure you can see that we do not have a perfect square in 73, and that's okay. Because typically these are either grid-ins or multiple choice. We're either going to need to round to some number, or if it's multiple choice, we could leave it in radical form. So there's 2 approaches here, depending upon what the question is. If I take the square root of 73, a couple of things first. If I want to reduce the radical, can I? Does anything go into 73? I don't think it does, but I also know that there's no perfect square that goes into 73 that allows me to reduce. 9 doesn't go into 73. I mean, we can start with the originals. There's no, 4 doesn't go in, and then 9 doesn't go in. All right, 16 doesn't go into 73 evenly. 25 certainly does not. 49 is already past the halfway point, so it can't. It doesn't reduce. So you could say, if this is multiple choice, this is the one approach. If it's multiple choice, then the answer would be the sine of theta. Again, sine is opposite over hypotenuse. So it would be 3 over the square root of 73, which hopefully we remember is not the final form of any math solution. We don't leave square roots or any kind of radicals in the denominator. We'd have to rationalize it. Remember how to rationalize it? I'm going to multiply by radical 73 over radical 73. That's the same thing as multiplying by 1. It doesn't change the value, it just changes the way it looks. So again, if I'm leaving this in radical form, I get sine theta equals 3 radical 73 over 73. Now, while that's not a very pretty answer, that would be the correct multiple choice solution. You can't grid that in. That would be a multiple choice solution. All right. So if it were multiple choice, that would be the answer. But if it were grid in, we're getting the same answer. I'll go to the original one. It's simpler. So right now, we have the sine theta is 3 over radical 73. If it's a multiple choice, if it's a grid in, we have to evaluate that. We don't have to worry about rationalizing if we're going to make it a decimal anyway. So really right now the question is, what is the square root of 73? Well, it's more than 8, because that would be 64, but it's less than 9, because that would be 81. It's somewhere in between. Wait, I need a calculator. For real. Be right back. Never be without your calculator. All right, so I need to figure out what the square root of 73 is. Radical 73, 8.54. I'll just round it to the hundredths place. So that's 3 over 8.54. So what is 3 divided by 8.54? 0.35. Rounded. That's a rounded answer. But 0.35 would be the solution on a grid in. Okay, that's all it is. If you happen to have a calculator at home, which I hope you do, or at least on your phone, this shouldn't be too hard. The harder thing would be having to rationalize. But so far as this homework assignment, very short assignment goes, I'll say make it decimal. So don't worry about rationalizing for right now. The assignment is attached to the classroom announcement. It's on page 485, numbers 12 through 14. It's just 3 problems. Shouldn't be too hard. Please get those to me no later than tomorrow morning, and have a wonderful day.